Good afternoon, ladies and gentlemen. It's my pleasure to welcome you online for this Space Careers Information Sessions Be a Star in ESA's Universe, which will focus today on space engineering and more specifically on robotics and photonics. I am Grégoire Bourban, Deputy Director of the Swiss Space Center, and I will be your moderator for today. This event is part of a series of 5 events addressing different themes like cybersecurity for space, space law, life support systems, and space science, with a focus on exoplanets, which will happen tomorrow. All these sessions are live on YouTube, and you will have access to our YouTube channel, Swiss Space Center YouTube channel, in the following weeks. We started this kind of events, space career events, already in 2016 under the mandate of the Swiss Space Office, our delegation to the European Space Agency. And it was under a roadshow going across Switzerland with ESA and the local experts. Due to the current situation, as you imagine, we decided to go online and therefore enlarge our audience. Of course, we keep a Swiss touch for this kind of event, but information here may be of interest for everyone coming from an ESA member states. So you will see now the speakers. I will just introduce them briefly, and then we will start the presentation. So first of all, we will have Mr. Lino de Faveri. He's scientific advisor at the Swiss Space Office, once again, our delegation to the European Space Agency, and he's in charge of industrial affairs. Then we will have Kyriaki Minoglou. She is head of the Opto-Electronics section at the European Space Agency. Gianfranco Visentin, head of automation, robotics and robotics section at the European Space Agency. Mr. Reto Muff, CTO of Thales Alenia Space Switzerland in Zurich. And last but not least, Florence Loustalot. She is talent acquisition specialist at ESA, and she will provide us with more information about the different programs for young people at ESA. We will have time for a Q&A session at the end, towards the end of the event. So please indicate in the chat, in the YouTube chat, to whom your question is targeted, and we will try to answer as much as possible all the questions around. We will also have a survey. It's important to have for us to have your feedback about this kind of event. So a link should appear in the chat, and we will also try to share as much as possible email address that you can ask questions afterwards. But do not hesitate also to contact us at the Swiss Space Center through our social media channels for more information. So let's start now with Mr. Lino de Faveri. Lino, I hope everything is now going well on your side. And well, first of all, maybe you can share with us what is your personal path through your education, and why you're now working at the Swiss Space Office, I think for more than 10 years now, in charge of our industrial relations.
Yes, good day to everybody. It's an interesting question, because in fact I am not at all at the start somebody coming from the space environment, but I was an electronic engineer, and gradually became interested in international cooperations and went on the side of the federal administration, and finally in charge of industrial affairs at the Swiss Space Office. Now, if I try to share my presentation, hope it's working. Is it fine, or? Okay, presentation, okay. Shall I? Like that, it's better? Okay. 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 Then the only point I didn't share was I'm working at the Swiss Space Office, which is a division within the State Secretariat for Education, Research and Innovation at Federal Department from Economic Affairs and Research. Okay. Is it not? It's not working. Strange. Ok, vous partagez. It's not. I went in presentation mode, but it doesn't work. Ouais. No. Oh, yes. Did you see the next slide? Okay. That's a pity. Sinon, je peux enlever les notes sur ici sur le truc là. Ouais, d'accord. Ouais, ok, merci. Okay. I think it's better. So I'm concentrate, sorry for that. My presentation on the Swiss space policy, to give a few words on that, and starting also with some historical facts and aspects which may be of interest, why Switzerland is interested in space since the start. And I'm going to end also with a few words on the user application and the carriers at ESA. So going now to the next slide. What is important, here you have the three pillars which are important for Switzerland participating at ESA. The first pillar is the curiosity. It means the scientists, it's providing scientists new tools to deepen the knowledge of in astronomy, planet science, and so on. And this was a strong move at the beginning when the cooperation in Europe started in the space domain. It was in fact a little bit inspired by what had just occurred in the atomic physics, namely the foundation of CERN. Then ESA had its special characters, and one of them, of course, is to have many missions and not a single instrument like CERN. And the second pillar has been the development of space capabilities for products, technologies which turn out important in space, in collaboration with European partners, of course, as it is in the case of science. And the third pillar, which has developed more and more in the last 10, 20 years, of course, are all the application deriving from the positioning system, Galileo for Europe, from Earth observation data, and also from telecom satellites. I will come to that at the end of my short presentation. Now, if I come to the next slide, important to know that Switzerland was one of the founding members of ESA at the beginning, when it was founded in 1975. Succeeding two others organizations which were merged, in fact, to create ESA. Switzerland was well known since the beginning for realizing the space, the Ariane fairings. Here you have an image of the Ariane 5 launcher in force since about 15 years. Ariane 6 is in full development phase and testing phase, and should have a first fly in about 2 years. Other Swiss products which are quite famous are the atomic clocks. So for Switzerland, it's not surprising, but believe me, atomic clocks have nothing to do with standard clocks, of course. Now, if I come to the next slide, and important to know the top-level objectives of Switzerland, of course, to foster competitive and sustainable national space ecosystem, increase in excellence and competitiveness of our science and industry, and also what is coming more and more the last years is, of course, the digital transformation of the world, and of course of Switzerland as well, which is an important fact. The last bullet is maybe more interesting for today. If you read the last line, promote education and training initiatives which certainly have a direct link also with career promotion, and to be stressed that it is at a high level objective for us, for the Swiss Space Office. Then a few words about how we realize our policy. Of course, ESA remains the main instruments. There are some activities also, especially in R&D, which are in the EU framework programs or Horizon domain. But mainly, in fact, ESA is our, in fact, used as our national agency, as Switzerland doesn't have an own national agency. And 95%, as you can see, of the funding is going to ESA. It's coming back to Switzerland via procurements of instruments, products, and other services. And then we have 5% of national complementary activities. Important to know that this is also a competitive approach. In fact, as in most cases, the companies have to win the competition. Although in the space domain, cooperation is also important, as a certain specialization of industry is needed to be very efficient in specific products and technologies. Then I've come to the next slide, hopefully. No, it's not working anymore. I don't know why, but okay, next slide. Yes. To give an idea of the technology domain at stake for Switzerland, of course, there are a broad variety of products and technology where Swiss companies and Swiss institutes are able to deliver for ESA programs and mission. But among these 5 areas have a higher priority than others. It means that in these areas we have in Switzerland competitive companies, but also competitive research institutes able to cooperate. As in most of the cases, it started with a cooperation and the technology transferred between, for example, an ETH or a university or a Fachhochschule and a company. So you can see the 5 domains. So high precision mechanism like pointing mechanism, deployment mechanism, and structures of satellites, structures of instruments, and so on. Time and frequency, and especially atomic clocks, of course, providing the whole Galileo constellation, for example. The photonics, which are emerging and quite interesting in the sense that it's for space, as you probably know, it's important to have high efficiency, but at the same time, very low consumptions and very low weight, and photonics is going in this direction. Then we have also strong institutes able to provide technologies like telescopes or spectrometers for scientific instruments. These are for the big and not only the big, all scientific missions of ESA. The last domain has to do with the exploitation of data and all the data, and to develop user-funded applications. Then you have some example of these technologies. On the left side, you have an example of structure of a scientific satellites. In the middle, you have an atomic clock, a major passive atomic clock. On the left side, a miniaturized mechanism, very miniaturized. And what is important also to stress here is Switzerland is since not so long able to lead ESA missions. So the first Swiss lead in an ESA mission was for Cheops. For Cheops is in fact the first mission dedicated to observe exoplanets. And the second mission where there is a Swiss lead. So Cheops was launched at the end of 2019, so exactly 1 year ago. The second mission here, Adrios, is totally different. It's about active debris removal. mission was adopted by ESA member states at the end of last year as well, but it is planned to fly in 2025. Sorry. Now I come with a few words regarding the benefits and daily use of space. Probably this is the main, not a big surprise for you, as you are the generation using apps and as everybody else, and even more in your day-to-day life. So it serves also to improve crops or forest monitorings and other such applications. And of course, all the applications having to do with monitoring of risk and hazards, as you can see on the bottom pictures. Important to note that in this specific domain in Switzerland, there are very small companies and SMEs active and innovative in this domain. And the last slide, a couple of words on our point of view at SSO, why career at ESA. There are several good reasons. First of all, it is a growing market. Not only public actors, but also private actors are important. I mean, companies, although Europe is still a bit different than the United States, of course, also in the size, but it provides many opportunity of career. ESA is also provide a broad spectrum, has to find experts in a wide variety of domains, not only in science, in usual exact science and engineers, but of course, this is a strong point. And important to know that there are what, in my view, two ways. I started at the beginning to say that I am now in space, but I was not at all bound to be in the space domain when I studied and in my first jobs. Nowadays, like 30 years ago, it's important for ESA also to have this second path of innovation, which is coming from people not having the typical space education, but coming from other sectors. And of course, ESA is a quite exciting place to work in multidisciplinary teams, working on exciting projects and missions. Okay, with that, I am at the end, and I thank you very much for your attention. If there are other questions, then maybe my email, or just ask them, Grégoire, Bourban, or the other people, because I'm sorry to say that I have to leave. I have another meeting now, but you are in good hands. I leave you in good hands, and thank you for listening to me.
Thank you very much, Lino, for this word. And indeed, so as you are leaving, thank you for your email address, and we'll try also to answer the questions that you may have in the Q&A session. Thank you. So let's go to this exciting place, so the European Space Agency. Engineering is quite a broad topic, of course, and we decided to narrow down to two domains, two specific domains, photonics and robotics. And so let's start with photonics. And now we have the privilege to have with us Kyriaki Minoglou. She is head, as I said before, of the Opto-Electronics section at the European Space Agency in the Netherlands. And maybe Kyriaki, also as an introduction, can you tell us more about your education and what you did before coming to ESA?
Yes, absolutely. First of all, hello, and I hope you can hear me well. And yeah, my name is Kiki Minoglou. I work at ESA, and I liked a lot the presentation of Lino before, because actually it triggered a little bit the fact to stress. I start from the last point where he said that you don't have to have the ambition to work for space since the beginning of your career. So when I studied electrical engineering, and then I did my master and my PhD on Opto-Electronics. And at that time, of course, I had no clue I will work at ESA. I mean, there are people who have this in mind and people who are just, they follow their path. So step by step, after my postdoc and after working also outside my country, because from Greece I came to Belgium, and then I ended up in Netherlands. We are located in Netherlands, ESA, ESTEC. I ended up in this post of Opto-Electronics, in the Opto-Electronics section, and now the head of the section. So it goes step by step. I would just give, if I wanted to give just a line on that, is don't focus too much on what you have done. I'm talking now to students, of course, and to people who are at the beginning of their career, but even for people a little bit more advanced, you can always follow your path afterwards. So I have a presentation about the photonics because I thought it's much easier to explain with some figures and some photos what is photonics at ESA. So maybe I can share. And let me do it here. Yeah, and still. So let me just change. Is it fine now? Excellent. So as I said, I will try to summarize a little bit what is photonics for ESA, but of course you can talk for much longer. Just to condense everything in 10 or 15 minutes, I will try to focus on the most essential and important. So I will skip the first part, which is what is European Space Agency and what we do, because I'm sure that at the end of the presentation there is a very extensive and detailed overview of that. So I will just focus on the technical part, which is about the photonics. So photonics, it comes from the word phos or photos, which means light in Greek. And actually it covers, it's the physical science of light, like the generation, the detection, but also how you manipulate the light, how you travel it through, so like emission, transmission, manipulation. And for ESA, the photonics largely refers to the technology of guided wave technology. So like, for example, optical fibers or waveguides. Now, why we have photonics? Because we are expected to have an impact like in all the commercial applications, the same for space, by replacing and enhancing the conventional electrical approaches. So instead of wires, you can have the optical fibers or free space. And some of the examples that we are going to discuss in the slides after is how about the payload, which payloads, what type of sensors, what type of technologies, and what specific applications. Some examples that were already mentioned, the optical clocks, for example. In Switzerland, they're very strong in making technologies on this domain. Now, as a general term, of course, photonics, they belong in optoelectronics. So with optoelectronics, we cover a big family that has to do with light and electronics and sensors. And so sometimes the distinction between the two is not so clear. What are the applications that we have for space? In a way, they're not so different from what we have also for ground applications. But here I give some examples. So we can have flexible payloads, even if they are based on radio frequency, but they have microwave photonic components. You can have optical interconnects for digital payloads. So how you even make, for example, two PCBs to communicate to each other via light. Photonic integrated circuits, the same like on a PCB where you can include also photonic components. But also intra-satellite communication. So inside the satellite, how you can communicate, for example, a space fiber. For the people who are more into the field, they can know that this is one onboard network technology based on photonics. Fiber optical sensing for platforms where you can have measurement, very accurate measurement of temperature or accelerometers. And then also photonic for launchers even. And for some of those, I have some slides that shows some more photos of what are those applications in reality. So if I go to the next one, I start with the most easy and the one that we all know, of course, and that we take advantage even now that we talk to each other. So what we know on the left part is the connection via fibers. And there you see all the links that you have with all the worldwide and undersea fiber optic routes. planned. The same thing that we have with the optical fibers, we can also have it in space. And that's what you see an example on the right-hand side of the slide. So here you have 2 satellites. This is an experiment not so recent. So it's been some years that it has been done. You have on the left a satellite from America, from the States, and then on the right you have a satellite, a German satellite. And they managed to have a link between the two using a laser beam. And they managed to be in contact and to communicate, send signals one to the other. This is a typical example of a communication link using photonics and free space communication. You can understand, of course, that the challenges are quite high because you have the laser beam is quite narrow. You have a high relative speed between the 2 satellites that they need to communicate, so that the pointing control is quite difficult to get. Now, as I said, that was an experiment of some years ago, and then there are many other implementations of this type of connection between satellites through photonics. You can see on the left. And on the right, you see an example of where we have reached around or in the order of 1,000 even communication and links per month for a total of 40,000 links. So that's a very big amount, and it keeps increasing. So there's a lot of payloads and a lot of satellites, which means a lot of components and a lot of technology and a lot of new technology also. And something about upcoming mission examples, you see here even a more complicated scheme where you have more satellites around the Earth and they communicate with each other, but also with ground stations. And on the bottom part of the screen, the bottom right, you have an example of a ground station and how this will communicate with a satellite, which is, of course, a graphical representation. So you have the laser beam from the ground station hitting the ISS in the specific case. So you have the ISS around the Earth. And an ambitious example is the project Hydro, where you will have a lot of fiber in the sky. So whatever was explained before with fibers, we will have it with optical communications. Now, what do we do at ESA? An example of what is relevant to this slide, for example, is the next. But here we have an optical ground station. But of course, to have it, the ground station in Netherlands, it wouldn't make much sense because you need to have, first of all, a mountain and also a clear sky and without lights. So our ground station to do this type of experiments and tracking satellites and tracking ISS and making the optical link between 2 points, we have it in Tenerife, in Spain, on a very high mountain. And that's part of our job to also do this type of experiments with payloads to check for near-Earth objects, for space debris, and quantum entangled experiments. Another application of photonics that was shortly mentioned in a few slides ago and before, and maybe it's not so easy to think about, that is about the launchers. So how can you use photonics for launchers? Because there is a new technology, it's a new approach for opto-pyrotechnics. The idea behind it is that you will use this approach for the detonation of the pyro. So you use a laser output that will ignite the pyro material, and that will use it will be used when you want to release the elements to be released. So in the section, together, of course, with the European industry, there are a lot of advantages and technologies working on that, and a lot of studies. And the positive thing, of course, because when you do research, one of the big reward that you feel is when this technology is being adopted and will fly, is the fact that for this technology, it will be the baseline for the next European launcher for Ariane 6. And here you see exactly the detonation that will happen with Opto-Pyro. And as a last example, I thought of putting something in a much, much smaller scale, although the components that are used there, they are quite small. The application looks big. But I decided to put the photonics used for optical frequency combs, which is what was mentioned also before about the optical clocks. Here you have an example of a silicon nitride platform. That was done with a collaboration with ESA and EPFL. At EPFL, there is a very strong and very important group with very good research done on this topic. The idea behind is that no longer a large complex instrument will be needed because we will manage to miniaturize the waveguide approach by using this silicon nitride platform. And there you have an example of how big it is, and of course you can see also the dimension on the photos, if it is 100 microns or 500 microns, so it's quite small. And this is quite a success story, not only because of the technology that has very good results, but also because two spin-offs they were managed. They came out of this of the lab doing this research, which I think it's a very important also element for the application of the technology. And also it was an example of a very good collaboration between ESA and EPFL and Switzerland in general, because it was there were students working with that, doing their PhD studies, and then in collaboration with ESA. But again, at the end of the presentation, I'm sure there will be a specific slide explaining the possibilities for doing this type of collaboration and working together. So very excited, very happy. What is it there for you, and how can you think if you like or if you fit in the picture? What is it, the technology domains in general that we discussed, but also we don't have time to discuss in 10 minutes. So it's about photonics, light generation. So you can have here different families of components, lasers, LEDs, light sources, systems, even LiDAR systems, but also optical clocks, applications for navigation. It was mentioned before also the Galileo, the optical clocks and launchers. If you're interested to explore more about what is photonics at ESA, and you are in the phase of looking for a new challenge and a new endeavor in your life, I put just the last slide about a summary of what we are looking for, because we are always looking for motivated people who have the interest about academic research, but also technological developments. We're not a university here, we do a lot of research still, but so we can cover different type of needs and interests. Curiosity, analytical skills, of course, teamwork. We are a group of, I would call it a group. At ESTEC, we are 3,000 people, so teamwork is one of the key elements of how we work together. And of course, multicultural environment. And of course, the last point, which then I'll decide to close my talk, relevant education, obviously. So yes, if you have done studies in electrical engineering, in photonics, in optics, in opto-electronics, if you have a master or a PhD degree, it is very relevant, absolutely. But if your studies are somehow a little bit to the periphery, also don't exclude yourself before investigating all options. That's my advice I would give. So that's from my side. Thank you very much, and I think we can have it also in a more open discussion if there are questions or more elements to address.
Thank you very much, Kyriaki. It was a very interesting presentation, and thank you also for your information about the type of profiles that you're looking for in your section. It was interesting also to see the importance of photonics for our satellites and spacecrafts around the Earth. Let's go now a little bit deeper in exploration, and usually robotics is for exploration. We see a picture of a rover going to Mars or also other planets like on the Rosetta, the mission Rosetta. So that's our idea of robotics, and from my personal view, when I am meeting you, Gianfranco at ESTEC in the Erasmus building, it's always impressive to see the trainees, the students, young graduates that are working in your section, and also with stars in the eyes and playing around with robots. So that's probably also a very good place to work at ESTEC. And we are happy now to know a little bit more about what you're doing at within your section, and also maybe what is your background in this domain. So, Gianfranco, the floor is yours.
Thank you, Grégoire. Hello, everybody. My name is Gianfranco Visentin. I work at ESA. I'm heading the automation robotics section. Since quite some time, it's 30 years that I'm at ESA, so I'm not really a freshman. I do, however, have still a freshman enthusiasm to work with the things that we are given to work, which is this amazing subject of automation robotics. I'm myself a control engineer. I graduated at the Turin Polytechnic quite some time ago. And I started actually my career not with space, although I must say I wanted to be working for space even before ESA was born. I had my inspiration were the Apollo landings, and I just wanted to do those machines. I found them so immensely attractive that it was a kind of a guideline from my early academic career. Anyway, I worked on airplanes, I work on cars, control of cars by means of actuator for self-driving, steering, suspensions, and so on. And one day I managed to come to ESTEC and work in the subject of robotics, for which I had already been trained during my years at university and industry. So what do we do in robotics? I guess it's time to start my presentation. So here it is, space robotics, particularly at ESA. So what do we do at space robotics? I plan my presentation to essentially give you, first of all, a flavor of space robotics. Robotics is a multidisciplinary subject, and it is used a lot into academic studies in engineering because it provides so many things that one can bring together. So it's the ideal system engineering activity. But space has additional features with respect to ground robotics. I will try to make a bit of characterization of what is a ESA project. I'm not sure that everybody knows what it means doing an ESA project, so I think it's nice to see what is a project, what ESA does in this, and also what we in the automation robotics section do. And finally, what you could be doing in this, how you could be part of this big scene. So what is, first of all, robotics in space? Well, we take a arrow going away from Earth and moving further in space. We have the robots on the space station, which is 300 kilometers of height. These are used for assembling the space station and for making services available to astronauts. If you move further up, there are, for example, robotics could be used for clean up the sky. Actually, the second Swiss-led mission is about that, cleaning the sky from debris that we've been making since the beginning of the space age. And then if you move further up, 36,000 kilometers orbit, there are geostationary satellites that these days are launched and left there, and they operate maybe for 15 years, and the only thing that we can do at later stage is dispose them. In reality, in the future, there could be the potential to service them, to maintain, to upgrade them, to make sure that they can be reused and even the materials reused as part of a circular economy. So this is orbital robotics. When we move further away and we go for the moon, okay, you see robots have been used in the early exploration, and they will be used again when we go back to the moon. And certainly they will be used before any infrastructure is placed there for humans, because, I mean, there will be need for other things than humans to build stuff, to build plants, to build housing. Finally, if you move further away in the robotics for the small bodies, well, robots are the only option to explore things which are so further away and so difficult to reach and so problematic even to come back that they are the only option. So this is the planetary robotic subject. The example I want to talk about is our rover, this ExoMars rover, which also provides an interesting opportunity for creativity in the sense that this is a rover, so it's a kind of autonomous car, but it has to work on a planet which is further away than anything you can think on Earth. And it has so many complexities in order to resist to the environment, but also to navigate in a place that has no roads, has no localization, and we don't know where it is going when it's going. So it needs to be autonomous. How do we do this project? Well, first of all, the project starts first with the idea about the project, and it is structured in phases. As you see, it takes several years to essentially launch something in space. You started with we have phases, so this is a standard way of defining our projects. They are defined in the phases, so you first study the technical requirements, whether it's good to do what you want to do. Then you assess the programmatic feasibility. Finally, in phase B, you confirm all the technical solution. Phase CD takes maybe 5-6 years to develop all the hardware. And finally, you launch and you use the system, hopefully for many years, but eventually it needs to be decommissioned. So you see, this is really taking a long time, and it might be scary for people who come young, but it's also an opportunity. But we don't do these projects just once in a while, because you see, for a project that is launched in space, you have several other projects that are starting and being studied at the same time. So this is what we essentially do each time we're trying to study opportunities that maybe do not become a real project, but require a lot of assessment, require a lot of experimentation, because you want to understand whether the thing you're proposing to do can be done. And so we do this in the section by essentially providing, first of all, the technology that makes this mission possible. So we use robots that are of certain derivations. They might be totally newly invented, or they have some sort of a terrestrial counterpart, and they need to be increasing their readiness to be launched. And this is done through research and development with industry, with academia, but it's also started with us, within ESA, within our labs. We provide the missions that are being developed with experts. So the people in the section is capable of providing expert advice and monitoring what are the activities at industry and academia, also performing some shadow engineering. And we also do this shadow engineering with involvement of the labs. And Grégoire was mentioning the labs. We have plenty of labs that have essentially, they serve three aspects of a space system. So when you have a space robot system, if it is on the planetary part, it needs to interact with the planet surface, which is dirt, which is unknown, which presents all sorts of features that you don't understand, but you need to measure and eventually understand. If you are in space, in orbit, you have instead, you're working on things that are made by humans. And there are other characteristics, like there is a lack of gravity, so everything becomes a little bit strange to manipulate. In any case, whether you are on a planet or you are in orbit, you need to interact with humans. And this is why we have these three labs. So we have a planetary robotic lab, an orbital robotic lab, and a human-robot interaction laboratory. Let's see, what do we do in those? So this is, for example, our planetary interaction robotics system. And all the people you see there, apart a couple of old guys, these are all trainees. These are all young people being here for 1 year or 2 years, essentially developing all the equipment that we use in order to look at the subjects of locomotion. How do you move on a surface that is never been seen and not even explored in terms of coherence, consistency, ability to move. How you navigate, how you move from one place to another, being not in touch with Earth and being alone on yourself, and also how you can maximize the operation of these vehicles that have a limited lifetime. And we do this in the lab from early conceptual design until final integration. And the lab itself is not only working in the lab, because the funny thing about planetary robotics is that the best environments where you can test things are in the outdoors. So we prepare our systems and we bring it to other places in order to make the best test, the most representative tests. You see on the left side, for example, with the means of young engineers, we develop the system. This is a test that is taking place actually in Zurich, took place in Zurich at RUAG, to essentially engineer the wheel walking system that allows the rover to climb very high slopes in very soft terrain. Or we brought, for example, this other rover with the mock lander to experiment remotely all the procedures for getting out of the lander after landing. Or finally, we went to, this is also Tenerife Island, very close actually to the place that Kiki was showing. We brought rovers in order to navigate in the day and in the night to show how this system of autonomously moving around can cope with the terrain it has never seen. And then we have, for example, the stuff that works in orbit. In orbit, one of the things that you need to cope is the fact that when you try to grab objects, if you are not grabbing them properly, they can just spin and get further away. So we have a lab in which we can simulate the behavior of satellites. We can simulate systems that can be grasped by other systems, like they are floating in space. And the reality, they are floating on an extremely flat surface that allows to essentially glide on a film of air. And we do this test again with trainees, and you see we can essentially dock and undock spacecraft that are floating on these blue things that are air bearings, they're called. And we have finally the human-robot interaction lab. And this is a lab that has a lot of robots and a lot of vehicles, because in the end, all these instruments, all these objects that are sent to other planets, to other surfaces, or on the space station, they need to interact with humans, and they need to interact with humans in a way that is intuitive. And you should not be the condition of training and retraining for months, and maybe the time you pick up the robot, you already forgot everything. So the robot system has to be commanded in an intuitive way, and this allows us essentially to send the knowledge of operation to astronauts. And this is an example of what we did at a certain time last year. We had an astronaut on the space station, you see it on the bottom picture, that was commanding a rover system in a hangar that we equipped with a mock lunar scenario. So from the space station, it was commanding this robot. This robot was also built with the help of young engineers. Well, the majority of the people who work on this was certainly below the 35 years and probably in average around the 25. And this was a very successful experiment. It demonstrated that an astronaut that are trained only a few hours could actually carry out the operation in very quick time. Actually, the guy was surprisingly fast, but also because of the very well engineered interfaces. So what could you be doing? So most of the in-house technology research and development in our section is done by young engineers, people who have graduated in the last year or have maybe just acquired PhD, and they are working together, putting together these systems, doing tests, checking the technology, or even taking our van, bringing the rover and driving to test the sites where we can acquire all the data that is needed in order to understand the good working of certain concepts. Young engineer participated to all these phase 0 studies that I was showing, because it's requiring quite a lot of analysis. And this is normally done by use of the concurrent design facilities. And we sent there our expert guys, but also a lot of young engineers. And finally, young engineers support more senior engineers we have in the section in all the reviews that are needed in order to guide the ESA projects done at industry or in academia. And of course, progressively with the years, they become more and more senior, and they themselves take up their duties. So all very interesting. I hope that you guys, considering what is the typical profile that Kiki was explaining, are interested in joining the agency and doing the nice things that we do.
Thank you very much, Gianfranco. It was very inspiring and very exciting to see these rovers around, and to know that, yeah, as a young engineer, you can directly work with this. So, well, working for ESA, that's of course an achievement, and we see here a few examples where you can work in these domains of photonics and robotics. On the other side, ESA is also needing some industries, research centers, academia around in the member states to work on the projects, and we decided to give here the floor to Reto Muff, so CTO of Thales Alenia Space in Switzerland, and we will ask you, Reto, to give us more information about what you are doing at Thales Alenia Space in Switzerland, and which kind of projects you are doing, and also maybe more a personal view on the profile and the career you're looking for when you're looking for a new person. So Reto, the floor is yours.
Thanks, Grégoire, and thanks for giving me the opportunity to address the industrial activities of Thales Alenia Space in Switzerland in the context of the two speeches that we heard. Let me introduce first quickly myself. So I hope you can see that presentation. So a few words about myself. I'm born in 1960, so also not the freshest in the company. But I have to say, and this picture visualizes nicely, I got highly infected by the space virus in the 60s. It was a time, it was mentioned before, where Apollo took place. I had the privilege to witness the missions flying to the moon, seeing the people walking on the moon. I then got a diploma in electrical engineering at ETH in Zurich. I took various jobs, meanwhile, in aerospace, medical, and robotics, but the virus, this virus, kept me always affected, and it ended up in our honeymoon when I was sitting with my wife at the Grecian beach, looking into a starry night, and I started, of course, talking about the moon above us. You can imagine in what sort of trouble I was when I used the honeymoon to discuss lunar landings with my just married wife. But we are still married, so 32 years ago, after, we are still married, and we're going strong. Since 2007, I'm now engaged in Thales Alenia Space in Switzerland, so I'm very glad that I could close the circle and come back to the space industry to more or less address the passion I got into during my childhood. When I was looking at what happened in 1960, the early days, I found that interesting information. It was a time when Russia and the United States were the only ones trying to launch rockets. And you can see they had approximately 38 launches with a success rate of 50%. These were the early days of space flight. Then 1969, the historic moment when the Americans touched the lunar surface, the success rate was already significantly higher. We were at 84% of all launches that made it successfully to space. But we can also see that Europe started to go towards space. Unfortunately, not with a success. As you can see, it was a first failure, but this is space life as well. You have to try. Sometimes you have to allow to fail. Of course, not with human beings, but you will never reach your goals if you don't dare also to fail from time to time. But of course, your success rate needs to increase, which happened for the space industry. And we can see in 2019, the success rate was already up at 95%, and the numbers of participants in the space business, the countries involved in the space business, launching rockets into space, increased dramatically. So what we take from that slide is definitely that the space industry has evolved from the experimental days in 1960 to a fully developed industry. And that means that this industry offers a variety of tasks and jobs for any type of engineers, but not only engineers, you will see at the end of my presentation. What is tomorrow? I was also wondering, and I looked, this is all from Wikipedia, I looked into what the future might bring, and I was very proud to see in 2025, it's already on the list of events happening, is the Bepi-Colombo orbit insertion at the Mercury orbit. You will see later on what the Bepi-Colombo mission carries. You see on the top right already an impression of the instrument that we have. So our company delivered a significant instrument to the Bepi-Colombo mission, which will enter into Mercury orbit in 2024. It's on its way. 2 years ago, it was launched. It's a long travel to Mercury. And so in 2024, we expect orbit injection. Before I present a few examples, I would like to give you a very short introduction in what Thales Alenia Space is. Thales Alenia Space is a joint venture dedicated for space business. It's a joint venture between the two big companies, Thales and Leonardo, as you can see with the shares indicated on this slide. And we have a sales of around about 2.5 billion euro in 2018. Thales Alenia Space employs on 17 sites worldwide more than 8,000 people, fully dedicated to the space business. And you can see a few examples of what we are addressing in different domains. So we have applications for science and exploration. We heard that before. So we go to the universe very far. We go to planets, but we also address scientific experiments that have that explore our Earth atmosphere. So we have all kinds of science and exploration activities ongoing, and Thales Alenia Space supports those missions, particularly also from the Swiss entity here. Another domain that is addressed by Thales Alenia Space is Earth observation. Earth observation are satellites that, as the name says, observe the Earth. And the purpose for this Earth observation might be weather observations, environmental pollution, vegetation, but also disaster recovery and alert activities. A very important domain, especially also for Thales Alenia Space, is the field of telecommunication. We heard that before. Telecommunication in the old days took place mainly with radio frequencies. In the modern days now, we are addressing, and you will see afterwards, also with laser communication, photonics, technologies, the telecommunication market in space. Originally, it all started with TV broadcasts, and you have voice and data communication, but more and more we clearly see a transition to complete internet communication in space. So we will have internet in space or in the sky, as people say, and we have seen an example when it was mentioned, the Hydron opportunity that is presently being developed. Navigation. In navigation, of course, everybody thinks about Galileo and GPS satellites. Yes, this is a domain on which we are working, but navigation also is used for traffic management from space. For instance, ship and fleet management is being managed by dedicated satellites orbiting the Earth. And last but not least, to mention, on most of these satellites, also the Galileo satellites, we have search and rescue transponders that can detect people in distress on Earth and can forward messages, distress messages, to rescue centers. Space situation awareness, a bit a special niche, so to say. In the space situation awareness, the goal is to monitor what the situation around the Earth is. We all experience from time to time solar storms. When the sun has solar storms, we see particles coming towards the Earth, and they can disrupt electrical power lines, but even oil pipelines have been affected by solar storms. Of course, meteorites, if they come close to the Earth, we would like to detect as early as possible. And then it was mentioned in the previous presentation, there are also debris, and many debris flying around the Earth, and they need to be tracked and categorized in order to avoid collisions with other spacecraft. This is the domain of space situation awareness. Human spaceflight was also mentioned. Of course, there is the ISS presently, is one of the biggest activities with respect to human spaceflight, but humans are going back to planetary missions, and there will be most likely not too far from now the first planetary habitats being put onto Moon, potentially also the Mars. Time will tell. So also clean space was mentioned. This is an artistic view of all the objects around Earth, and it's getting populated every day more. So there's a huge amount of active and passive objects around the Earth, and it is clear that sooner or later, if this continues to grow, this generates a problem to human and non-manned spacecraft. So there is nowadays significant activities underway to try to remove major debris from the Earth orbit. A young field, but I think it's a very important field if you want to have continuous and sustained operation in space. Now I come quickly to some information about Thales Alenia Space in Switzerland. I have here the mission statement. This is our mission. This is the mission that we have since several years, and it is nicely summarizing what activities we do here from the Swiss side. We are around about 70 people, highly dominated by engineering, but we also, of course, have other professions supporting the engineering stream here at Thales Alenia Space in Switzerland. So our mission is to provide small and high-performing optoelectronics observation and communication systems. As you can see, these two domains, observation and communication, of course, fit nicely into the mission domains that I just presented. Our strength is definitely optoelectronics. And when we talk about optoelectronics, you will see later, we always or very often have to orient and point laser beams into different directions. And therefore, also robotics and precision mechanisms play an important role. Some concrete examples. I already mentioned Bepi Colombo or BELA, the laser ranging instrument to map and characterize the surface of Mercury. So it's underway. It's about half of the distance to Mercury. This is a LiDAR, so it will send out a light pulse. It is reflected from the Mercury surface and is detected on the LiDAR. And with this reflected pulse, we can measure the time hence the distance to the planet, but also the constitution of the soil on the Mercury planet. This is definitely a science mission to characterize the consistency of the Mercury surface, which will give very important conclusions with respect to the roots of the Earth, because there is a connection between the consistency of Mercury and our home planet. So you can see on the top the spacecraft that is heading towards Mercury, and below is a view of the flight model of the Vela Bepi Colombo laser altimeter. A bit bigger view clearly tells you we have telescopes, we have highly stable mechanical structures, but you also see the fiber connections, which gives a clear indication there is, of course, a lot of photonics components on this instrument. And the back end is mainly then electronics and processing algorithms, but it's really a system that combines our photonics tradition together with the electronics and the thermomechanical engineering. In this case, we don't have robotics in place. The ExoMars rover was already mentioned, and we are very proud that we have two equipment on the rover. The very interesting one is CLUPI, close-up imager, which is in principle a microscope. Because it's a microscope, it needs to have a variable focus camera, and that brings, of course, mechanization and a little bit of robotics into the instrument. It's a camera, a color camera that will be sitting on the drill box of the rover to watch how the drill operations are taking place and how the debris coming out of the soil look like. One of the challenges was also mentioned are the very harsh temperature ranges that we will experience on the Martian surface. So to survive, we have -120 to +120, and we have to operate in -35 degrees C environment. Very nice picture. One would even say it's an artist's view. It's not. It's a picture of the real flight model that is presently already mounted on the Mars rover. Gives you an impression of this very nice piece of hardware. As I mentioned, on the rover there are two instruments, and this one is the other one. You see a very small, one would say even a GoPro style camera. So this is a black and white camera that will sit on the mast of the rover. Two of them that will give them panoramic and stereoscopic imagery from the Martian surface. This is called the PanCam. Also here, same problem, large temperature ranges. Now I would like to focus a bit on optical communication, as it was already introduced. So also on one of the slides before, we saw that we have here developed what we call Opto-Mu. The name already says Mu is a small terminal, so it's a laser communication terminal for small satellites towards Earth. It provides a 2 gigabit downlink data rate with a footprint of 8 liters, and only running at 45 watts. It's a modular design to ease the accommodation on small satellites, and you can see that on the picture on the left-hand side, where you see the satellite with mounted optical head. The other equipment is inside of the satellite. In order to support that mission, the in-orbit demonstration, which is expected to happen very soon, we have also established on the rooftop of ZHAW Winterthur a small ground terminal, a ground telescope that will be able to retrieve the laser link coming from Opto-Mu during its in-orbit demonstration. Other ground stations are being developed and deployed. We also saw the one on Tenerife, which we will be gladly using then also during our mission. Here's a picture of the optical head, so the part that is outside of the spacecraft, and you see the aperture, the round dot in the middle, more or less where the hand is. This is where the laser beam will come out, so this is 1.5 centimeters, not really big. And you see already in the back, behind the thermal shield, you see some gearboxes and motors. So this is a fully motorized optical head that allows to orient the laser beam into any direction. Here we combine really photonics with robotics or mechanisms to allow to acquire the ground station and to send the laser beam with its data modulated on it towards the ground station. This slide shall give you an impression of what talents we need in order to make such systems, and I think optical communication systems and terminals are the most complete of our activities here in Zurich. So we need laser and photonics technologies, optical design for telescope and optical benches, mechatronics and controls, because we have to be very precise with the pointing of the laser beam, optical sensors to retrieve the beacon signal coming from ground, control engineering, then a relatively complex communication scheme to have different modulation and codings to go through the atmosphere with the laser. This is not something that is obvious, but with the specific communication schemes, we can penetrate the atmosphere. Then, of course, operation and software. We have to make sure that this terminal will be operating quite autonomously. And in space, we always face the problem of temperatures. Sometimes we are sun illuminated, sometimes we are in the shadow. Therefore, we have high temperature gradients, and this gives distortions into our equipment, which is not ideal for optical equipment. Of course, we have to manage the power. Power is precious in space, so we have to carefully manage the power and distribute it. And then, as we go usually for quite novel approaches, we have to look into novel materials and processes. These are all talents that we are mastering here in our site. But as we are only 70 people, we of course depend on partners, we depend on institutes, we depend on trainees, we depend on expertise from ESA. So it's in principle a large teamwork, but we are the prime of that instrument and we have to stand for its performance at the end. So what talents do we need? I put engineering and technology into the focus as this is the theme of today, but I would like to mention that we of course need also other people working with us, and they're part of our team. Of course, we need the sales and business people because they have to acquire business in order to allow us to generate revenue and to develop products. Product assurance and quality, something of utmost importance in space, because in space there is no option to go for repair and maintenance. Once something is deployed in orbit, it has to operate or it fails. We cannot repair except from potentially fixing some software problems. But therefore, product assurance, and also here is an engineering task. We have to engineer the product assurance and the product quality. It's hand in hand with our engineering team. Then, of course, we have to manage a project as it was presented through all the phases from 0 to F. We have dedicated teams for integration and test of the hardware, partially supporting also launch campaigns in Kourou or Cape Kennedy. We have to procure and ship parts. This is procurement and logistics people. And last but not least, we need HR and finance people to support our business activities, to get new people in, but also to send the invoices and to pay the bills. This shall give you a quick overview about the industrial part of what we presented today. I think many opportunities exist. I'm looking forward to meeting you somewhere in the space universe. And for today, I wish you inspiration. If you look up towards the east, the full moon is rising, and I think it could give you a very nice inspiration for the space business. Thank you very much for listening.
Thank you very much, Reto, for this inspiring talk and all the examples you gave. Very interesting also to see that space engineering is about partnering with other entities, working for ESA, and also having different kind of profiles around you in your company and around as a suppliers. So I think it's a perfect time now to have all the information we would need about how we can work and orient our careers, orient our studies to handle in one of these companies or to handle to finally work at ESA. So I will let the floor now to Florence Loustalot. She is talent acquisition specialist at ESA in the HR department. And well, Florence, let us know how we can do now to work in the space.
Yeah, okay, is that okay now? Okay, thank you very much. Good evening, everybody, and thank you for all the very interesting presentations, which in fact you will see have a clear link to what I will be able to present and the profiles we want also in general at ESA. Like my colleagues, I just want to say that I've been working for quite some years now in ESA, and yeah, also interestingly enough, initially I was not meant to work in space, but from Bordeaux, where I lived and studied, to Noordwijk, where I arrived some more than 10 years ago, 15 years actually. The path went through various organizations, industry, various countries. So why do I say that? Is that also when you don't work as an engineer or as a scientist, there is not only one way to a destination. So you find your way in your career little by little. Each experience brings you something. And what I always like to say is that there is one driver, and the driver is your pleasure, your motivation, and your interest for something. And then you see that your career has a logic. Now, let's go back to the beginning of a career. And we have at ESA a few programs, and the first one to help you start career is the student internship program, which is for the students who are in their last or second but last year at university, in particular, let's say, and which is a program from 3 to 6 months, where you are a student, you are working with tutors, with experts. And this program this year, unfortunately, and as you can well understand, will only be organized through remote placements due to the situation that we all know. Very, very few topics will be, and I see Gianfranco nodding, very, very few topics will be in labs. But that's the only ones which we will be able to welcome on site. So these internships offers are going to be published this week, actually, for 4 weeks, and for your placement in 2021. In general, they start in February. Then we have another program which is also quite known in the students community, engineering and scientist community in particular, is the Young Graduate Trainee Program. So the Young Graduate Trainee Program is for the students who are about to graduate or at master level. That's very important, at master level. Or I've just graduated. Maybe you have 1 or 2 internship experience, that's fine. But the idea is that the YGT program, the YGT experience, is an on-the-job experience where you, coming from university, bring your fresh, very fresh idea, innovative idea, creativity to ESA, where you will work with experts who have been working, you've heard, on all these projects for many years, maybe. And that's a very interesting, let's say, program and opportunity, because you also work, as we will see and as you have heard, in a multicultural environment. The community itself of YGTs and students and research fellows is a big one. It's dynamic. All the students and let's say young graduates speak together and exchange. And at the same time, you are also given some autonomy to do your experience. So it's a very interesting program. It's for 1 year or 2, if you are extended for a second year. And all these opportunities will be published in February 21 for a recruitment in September, October 21. Okay, so I will go further for the profiles in a later slide for the profile we are looking for, but you will see that there is a lot of similarities with what Gianfranco and Kiki have said. So then we have the national trainee program. The national trainee program, the trainees have the same profile, I would say, as the YGTs. Just have a master at a degree at master level, but the difference, let's say, is that their recruitment is done through the national agencies. So we have Switzerland as a program, and in fact, we have recently made the selection for Swiss national trainees. When they are in ESA, they are, let's say, considered in the same way as the YGTs. So they have a tutor, they work with experts, they work with the other YGTs. And if there are questions, let's say, on of logistics, we adapt, let's say, the national trainee programs to the YGT program. So, and again, this is also for a 1 year contract, and sometimes 2 years, in general 2 years, I should say. Now, the research fellow program is a bit different in the sense that we look for people with a PhD. So our research fellows, internal research fellows, have or are just about to get their PhD or have just got their PhD. Sometimes they have a few years, maybe up to 5 years also research work after the PhD. And they are mostly in the science, space applications and technology. It's a 2 year contract and sometimes a third for renewable for a 3rd year. In this case, we don't have a specific campaign like we have for the YGTs or the students. Okay, it goes all year long. In fact, actually we have still, I think, something like 8 opportunities published for research fellows at the moment. So if you are interested, you can have a look, of course. And for the three programs, we look for citizens of our ESA member states or citizens of the European cooperating states, together with Latvia and Slovenia as associated member states, but also of Canada as cooperating states. That's very important to remember. I will now go to last but not least program, which is a little bit different in the sense that it's not managed purely by ESA Human Resources, but it's a cooperation program between university and ESA. And the people participating to this program are not staff, ESA staff. The projects, the research program is co-funded by ESA up to 50%, or up to, as you can read, 90K at PhD or post-level, and it's at PhD or post-level doc level. In this program, our colleagues look really for, I would say, out-of-the-box thinking, innovative ideas, creativity. So you can also go to our website and look a little bit what they propose if you are interested in this program. And by the way, the people who are participating to this program are still at their university. In fact, the cooperation is between ESA and the university more than with ESA and the person. Now, what kind of engineering disciplines do we look for? So you have heard a lot about mechanical, optical, thermal mechanism, but we also look for electrical engineering, systems, software, telecom. So the range of engineering profiles is enormous. And I think it was Kiki saying, or Gianfranco, but I think it was Kiki saying, if you have studied an engineering discipline which is not specifically written here, just it should not stop you for having a look at our website and the opportunities we are going to publish in February. That's very important. Then we also have scientific disciplines, profiles with scientific disciplines like Earth observation and environment, geophysics, meteorology, but also in planetary and space science with astronomy, astrophysics, and solar physics, but also in life and material sciences. Of course, to have, let's say, engineers and scientists working at ESA, we also need the support functions, and therefore we also need lawyers, we also need finance people, communication, HR, IT, which is also a very important discipline, and facility management. That's for the technical background, but in general, we are also working for all those of you who are passionate, the ones who have who have an interest for a multicultural environment, the ones of you who have a team spirit. It's extremely important to have this let's say interest and motivation for multicultural environment and working together, and to have the pleasure, again I come to that, the pleasure of working with others, with experts and with your peers, with people who don't have the same background as you have. Not the same background in terms of education, but also not the same background in terms of a cultural background. So you see here now a slide which shows the word in the middle, diversity. Yes, we are an organization who is looking for diversity and who wants diversity within the workforce. We are an organization who's looking for a friendly working environment and to develop this, let's say, working together, as I said before. Voilà, now you can see, this is my last slide where you can see the website and our address where to go and visit the site, what we do in general at ESA. And if you go to careers, then you will have a description of all these programs I've talked about so far. And with this, I give you the floor back.
Thank you very much, Florence. I think it was a very detailed presentation on the opportunities you can have as a student, young engineer, young graduate, in fact, in general, to work with ESA, also doing a PhD or co-funded PhD or postdoc, then directly at ESA. So indeed, all this information can be found on the ESA website. I propose now that we move in the Q&A session, because we got several questions in our YouTube chat. So basically, there are questions more in general about, as you can imagine, what is the importance of doing a PhD in the domains, or master, is it enough? That's the usual question, and I will address that. And then we have more specific question, very specific sometimes, especially for robotics, for example, where let's see if we have time. Otherwise, maybe the people can contact you, Gianfranco, afterwards. But let's start maybe with more the generic question, and with you, Gianfranco, also. So for your domain in space robotics, what do you think? It seems very, let's say, hands-on, and also the way of doing a PhD. Can you elaborate about that? What would it be useful to do a PhD, and would you have any advice for PhD studies in space robotics? Any examples that you can give here?
Well, PhD is a personal choice. You may go into academic studies and go for a PhD if you're really interested in the subject of research with the aim of publishing papers. You don't do only research in the PhD studies. You can also do a lot of very interesting things working for industry or even working for ESA immediately. And the means are there, are available to many. I mean, it's not because you do a PhD study that you don't do mathematics, you don't require an academic approach into doing engineering. It's just a different orientation. Your product in a PhD are papers and of course the thesis. In industrial studies and work at ESA are project outcomes, deliverables. In any case, I think in robotics these days, almost nobody does work only on theoretical studies, because one thing is putting together equations and doing simulation, but it's extremely important that actually you embed what you have done into some hardware. Robotics, I was mentioning, is a science in between several other disciplines. So you really need to bring those things together into a physical prototype in order to confirm your idea and to confirm also your result, whether this is academic or industrial. I don't have a specific advice. It's in the end, if you're coming to ESA, you're valued for the experience you have done, whether it is in an academic or industrial concern.
Thank you, Gianfranco, for your answer. I will also ask kind of the same question to Kyriaki about your topics in photonics, because we have the feeling, thinking about photonics, which is maybe more close to the research still, but you show in your presentation very concrete engineering applications there. So taking maybe an example in your section, very concrete in your section, did you have experience in conducting PhD people around, so also in co-founding with ESA or having PhDs in your section?
Yes, absolutely. We have a very close collaboration already years. This is going for years. So we have an expert in the section, Iman Murphy, and he's dealing with a lot of PhD students. So I think continuously there's either YGTs or NPIs, which is the PhD students. And the main the topic discussing that they are investigating is about optical frequency comms, optical clocks, which it sounds indeed very theoretical. But as we have seen also in the presentation of TAS, at the end you have a real demonstrator. You have an actual device that you fabricate, that you have to test, that you have to characterize and then come back and do some modifications. But yes, we have a lot of experience, and actually even already last year he opened another topic. So it's something that it's ongoing. Yes, absolutely. If people are interested in that, they should definitely come in contact with us and we can discuss further. So
thank you. We can basically summarize this question as you need, in fact, the full value chain. Let's say from the theory PhD in physics towards the more application engineering that we get.
Yeah.
And well, I think maybe we can also ask Reto with the industrial experience here. Of this background that you would see. Of course, you give examples of more soft skills that you would see, and also some experience that you would need, but also in the idea of theory versus application. What is your feeling in the industry?
With respect to PhD, I cannot speak from my own heritage. As an engineer, usually it was not so common to make a PhD, which I do not regret. I went to industry and made my nice experiences, but I can say from our company point of view, we are presently working heavily with PhDs. The PhDs, however, usually are in academia, and we have partnering with academia. So we have projects. Ian Murphy was just mentioned. We are presently having quite a cool project with a university not too far from here. There, the PhDs are very stronghold for our activities because they are really dedicated. It's a phase, an intensive phase of their life, I believe. I don't know, a few years probably. This is very intensive. They know that, and they go with full speed on the subject, and they are not distracted by daily business as we are sometimes in industry. So to have a collaboration with the PhDs, with academia, is so valuable for us. It's very helpful and inspiring. And at the end, it's even better if at the end the PhD then, after his PhD career, changes to industry and picks up on what he did and what he experienced in academia. But then, of course, life changes a bit. It's not a research life in industry usually. It's not about papers. It's really to provide hardware, to provide results, as it was mentioned. But this is not a contradiction. We collaborate with academia in this respect.
Yeah. Thank you very much, Reto. Now maybe a question for Florence about the current situation. You mentioned that next week you should open internship positions at ESA, and very soon in February for young graduates also. Well, we don't know exactly what will be the situation in February, but for the interns, you mentioned that it will be fully remote. Most of them will be remote access. So do you know already if there will be some special conditions with respect to the different aspect of being intern at ESA? What will be your implementation from the HR and from the sections to make this experience as closer at what it was before, and also more specifically in terms of, for example, salary or accommodating the rent and things that you already do when the people are moving to ESA in the ESA centers. What could you say about the conditions there?
Okay, so that's a broad question. First of all, we have already worked like that since March, actually. Yeah? Nearly all year long, we have had remote work for the YGTs who have started, and national trainees, even if they have come to, for example, Holland or to our other sites in Germany, ESOC, or Italy, SERI, or EXAT in England. Our YGTs and national trainees have worked like us, staff, teleworked. Okay, so there has been, we have tried, and I hope we have succeeded in having a tutoring as close as possible from the experts, the managers, to the trainees, be them the national trainees, young graduates, or even the students. However, already this up to now, for the students who are younger, who have less experience, and who come also for only 3 to 6 months, when a stage, an internship was, let's say, doable from a distance from home, we have done that too. Because you don't want to have a student coming to a foreign country and then be locked at home, because we don't go a lot to the facilities. So in the teams, they organize, they have some, Gianfranco could maybe speak more about how his team is organized, for example, or Kiki, but it's not that the students go on site at ESTEC every day, like we normally do in a normal situation. Okay, so all this has to be taken into consideration. We are nearly examining all this. And when I say that we have now opened all the opportunities for remote internship, it means that the tutor and the student will work together, not in presential, not in face-to-face. They will be at home in France with a tutor in Holland. And at this point, of course, what we normally give for, let's say, expat student, we don't give because they don't come here to live here in Holland. So the amount is reduced. of the not it's not a salary, we call that, it's a reimbursement of expenses, let's say. Now for the YGTs and the national fees, the research fellows, we open the positions so far normally, and then we adapt as with each month we have adapted the situation. So we have had quite a few of the YGTs or research fellows coming and having to stay at home, again working with the tutor from home, I mean in Holland, and they receive the salary as they normally would have received it if they would come on site, because they work from home, but they get their computer and then they work from Leiden, Noordwijk, Frascati, wherever they are posted. It's not in all that, but we are doing everything we can so that we maintain our stage traineeships programs with as much as possible relationship between the tutors and the students. But unfortunately, like for many organizations, health is prevailing over being together and working on site.
Okay, so thank you. I think it was very clear answer here, Florence, and I guess it will be also detailed on ESA website when the position will be open. Back to more technical things about robotics and about artificial intelligence. So you show a few information about what are the projects you're doing there, and the question was a person doing a bachelor in artificial intelligence. And what should be the orientation of the studies afterwards to be related more to the automation and robotics that you mentioned? So maybe you can, Gianfranco, elaborate more on the artificial intelligence in your section.
Well, artificial intelligence is very important for many subjects in ESA, and not only for automation and robotics, because it is more and more used for analyzing the data that comes down from our satellites, which produce terabytes of data weekly. And so this cannot be analyzed by anything else if not by this automated AI. In robotics, we use it for various purposes. For detection, for example, is an interesting technology. For scheduling the operation in terms of space and time. There are several aspects of AI. So it depends very much what is your orientation. A lot of AI that is talked these days is just artificial neural network and deep learning networks. But in reality, there are a lot more technologies belonging to the group of AI that are important for automation robotics. So I can only say, please don't focus yourself only on one technology, because you might discover that by the time you go out of the studies, it's a little bit less of fashion. It's important to keep yourself on the different branches of AI, because some of these will be used, if not in automation robotics, in space in general, but definitely in other sectors of technology.
Okay, thank you, Gianfranco. Still for you, another question about in-orbit robotic construction. Are we entering a new age here in in-orbit robotic construction, allowing more space station or space activities when we think about what is happening in the launchers area with announcement of a lot of capacity payload like Starship, 100 tons to orbit? So what is your feeling there? Is in-orbit robotics something well, in the near future coming really as a hot topic?
Hey, of course, I can only say yes, but one has to understand that actually assembly in orbit is something that has been already happening by means of robots. The entire space station was built by robots, so it is already something that happened. What is going to happen probably in the coming years is that more stuff will be deployed and assembled in space by robots, because with larger infrastructure, it becomes even more difficult to pack a satellite inside a rocket. So to unfold this gigantic structure, you will need more and more robotics. And we are working on two directions. One, looking at interconnects that allow you to build up space structure made of modules, which are much smaller than the current modules. Nowadays, the space station is made of modules that each one is in the order of meters of size. We're looking at modules which are in the under the meter size, and also at assembly technologies, which for certain subjects like mechanical parts, we can do manufacturing in space by 3D printing. ESA is about to launch for the space station a metal 3D printer that will demonstrate in space how you can actually make mechanical important subjects in space, and at the same time by assembly, metal sheeting, by technologies in order to build strasses, to build antenna reflectors, things that can have an important impact on a mission, but do not require the very careful assembly of humans that can be automated a lot. Yeah, these things are happening. We're already working on those.
Thank you very much. Maybe, yeah, a last short question, because we are already later than expected here. And again, it will be still possible to watch again the presentations on YouTube. Maybe a last question. Well, it could be in general, but it was directed to you, Reto, at Thales, about language, but I think ESA can also answer. I think English is very important, but for a company like you in Zurich area, well, do we assume that German, French, other language should be also important?
And whatever important means, indeed, English is our main language here. We have here around 70 people working for us, as I said. And I didn't make the last count, but we have probably 15 nationalities here. So we are very international. This is maybe specific to Switzerland. Some other TAS sites are less international, but here we are very international. So the language on the site is English. We sometimes detect, even if we are all Swiss, German-speaking people in a meeting, we speak English. Then we ask ourselves why. And it's just a habit. It's really English that is most important, because also this is the language around industries. But of course, it's nice if you speak a local language, which could be French, Italian, German. But this is really secondary importance for us. English is the most important language.
Yeah, thank you, Reto.
What I can also say, of course, if people come from abroad speaking non-German or non-French, we of course offer also education, not ourselves. I will never be the teacher for this, but we have schools around, and therefore we can send people, and we support this, that people get local, because we would like to keep them here. So we appreciate if they get local, and so German and or French, Italian is definitely appreciated.
Thank you, Reto. I think it will be well the same for ESA, of course. So English, the most important language, but of course all the language, different nationalities, it's very important, and you're also offering opportunity to learn the language. So that's well, I will keep one of your words, Reto, as a conclusion here. International. Thales Alenia Space, also in Switzerland, is very international. I think it's the case for most of the activities in the space domain. It's about partnering, it's about the network, it's about international. We know the International Space Station, for example. The future of space exploration will be also a cooperation between states. So that's really a key here. The other takeaway here is about the no wrong way, basically, of you can orient your studies, let's say, as you want or as you prefer, or where you feel most comfortable, and then find your way around being in robotics, being in photonics, but being in the space in general, we saw a lot of examples where competence are required, and so you will find your way. So no wrong door, no wrong way in your studies. We also keep as a take-home message that there will be concrete job opening very soon at ESA. So for intern, still students who can apply there and do an internship, and then very soon in February for young graduates. And although there are a lot of opportunities for PhDs and postdoc, and of course for staff, there are vacancy notices open on the ESA website. Well, last word to conclude, I want to thank you all for your availability to be in this session, and more in general to all the people participating to this kind of event, Be a Star in ESA's Universe. You can still watch all the live streams on our YouTube channel, and this one will also be available in the YouTube channel. So thank you very much to all of you, and yeah, let's continue to be inspired and excited about space. And well, thank you, and have a good evening. Bye.